Hello and welcome to the NR322 video lecture for Lesson 7a. In this part of the lecture, we'll be talking about clip and project, and selections will be in a separate video. Now that we'll be teaching the rest of NR322 online for the rest of the semester, here's a little roadmap. So Lesson 7 has 3 parts. We'll be doing analysis with vector in 3 parts. So today, right now, and then overlay analysis in 7b, proximity analysis in 7c. And then we'll take a little diversion and do data integrity, data quality, how to measure error. That'll be lesson 8. And then lesson 9 will also be 3 parts, and that will be on raster. So that'll be in 2 weeks. In this lesson, in Lesson 7a, we're going to kind of walk through a pretty typical workflow or a typical scenario for how a person might be starting a project, and you might download data from the internet. You have to download it, you have to unzip it, and then you have to get it ready for use. So sometimes you have to pre-process or prepare the data before you can actually do your analysis. So one pretty typical example is that you get data for the whole state, but maybe you only need 1 county or 2 counties. So for that, you would use a clip. The next thing that's pretty typical is that you download data, but it's in a geographic coordinate system, and you want it in a projected coordinate system. Very often, especially nationwide data, is given out or available for download in a geographic coordinate system. Lat longs, WGS84, just because it's easy and it works for everything in the whole country. And then once you get just the piece that you need, then you can reproject it with a tool called project. You can reproject it into the local coordinate system that's best for your area of interest. So that would be this one right here. And then the third thing, which will actually be the second video, that is, let's say you get data for lots of different types of categories, and you only need 1 category, or you only need a certain type of feature, or you want to ask questions and start your analysis. Very often that's done with a selection. So selections will be covered in the second video. Let's talk about clip first. Clip is pretty straightforward. It's just a way to take an input data. So if you look at the mouse here, take your input data, and it's too large or it covers a larger area than you need, and you need to clip it down or trim it down to the extent of another layer. So the second layer would be like your cookie cutter. So here we have a circle. So the top one would be the input, the cookie cutter, that is the boundary that you want to trim it down to. That is your clip layer or clip feature. And then the output will be a brand new feature class. You're not altering the original. It's like you're making a copy of the input, but that copy has now been trimmed down. And your output will have the original data in it, the original shapes, the original polygons, but the boundary of it will be trimmed to your clip layer. In some cases, you can also use a select by location. It just depends on the situation, and we'll take a look at that in the demo. So let's take a look at the next thing here. After you clip your data, you may realize that the projection is not right, and you need to fix the projection. So there are a couple of ways to do this. One is that you can just change the properties of the map. You can make the data draw, make the layers in your map draw like they're in a different projection. We call this project on the fly, and that's not really changing the projection of a data set. That's a little bit different. It's just visual, it's just temporary. Usually what you want to do, especially for analysis, you want to truly project the data with the tool called project. So here we're looking at the toolbox, and you can see there's a few different tools related to projections. There are 3 that are probably going to pique your interest. The project tool is just for vector data. There's also a project raster tool that, guess what, is only for raster data. And then there's another one called define projection. Define projection is a way to change the properties of a layer and how the system interprets the coordinates that are there. You usually don't want to run that one. That one's very uncommon to run. You would usually only run that one if your layer property said it was unknown. So that's not as common. Let's go into the demo, actually. We have ArcGIS Pro up. Let's go into the demo and we'll go through this workflow. So let's start out looking at downloading data. So in this demo, we're going to take a look at some oil well data for Colorado from the COGCC, and then also some roads. So let's just do a quick Google of COGCC GIS data download. If you Google that, you'll get a few results here. And if you click on the second one, it'll take you to this page here. So this page is the COGCC GIS page. And what we want to do, we don't really want to go to the database, we want to go to downloads. So if you click on downloads, these are all the data sets that they have available for download. A lot of them are just tables, and we don't really want that. We want shapefiles. So if you scroll down, here are all the GIS layers that they have. Some of them are shapefiles, some of them are Google Earth KML files. But if you look at the shapefiles, they have well surface location data, oil and gas location data, facilities. If you keep going down, there's some other things as well too. So what you would want to do is download this data set. Just click on it, pick which one you want, which is well spots, and then it'll download it. What you'll get is a zip file, which you would then have to unzip into a folder, and then that will give you a shape file that you can add into the map. So I've done that. It's still downloading. I've done that. Let's go into here. So I went to my zip file, I unzipped it, put it in a folder, added it to my map, and then I had this right here. It takes a long time to draw because there's a lot of points. Wow, okay, there they all are. But it's for the whole state. And let's say that we're working on a project only in Larimer and Weld counties. We don't want the whole state, we only want those two counties. So we have to clip it down to those two counties. So here are two ways that you can do it. The first way, I said that sometimes you can use select by location. You could. So in this case, if we just select the two counties that we want, now Larimer and Weld are selected. If we select the two counties that we want, we could do select by location. In the select by location, it's going to ask you what layer you want to make the selection on. Your input features is the layer you want to make the selection on, and that's our wells. And we want wells that intersect layers in this feature, counties. Because we have a selection in place, it's only going to look at the two counties that are selected. So we could set it up like that and hit run. And after it's all done, it will redraw and show us our selection. So there they are. Those are all the points that fall within the two counties I selected. So select by location works for points. What it doesn't work for is if you have a line or a polygon that straddles the boundary that you're selecting by, it's going to select the whole feature. Clip will actually cut the feature in half and only give you the part that falls inside it. So clip will go a little farther. Let's run the clip tool right now. So let's turn this off. Let's clear my selection here. We'll do that way. Let's clear my selection and let's go to the analysis toolbar, analysis tab. And there's a link to clip right here, or you can go into your tools geoprocessing window and look for clip in here. You can just type it in and say clip. There you go. This clip tool is for vector data. Notice that there's another one down here for raster. We'll get to that in lesson 9. So I'm going to run the clip tool. I'm going to, again, reselect my two counties that I wanted because I need that. So I'm going to clip my wells for the whole state. My clip features will be my counties. And again, because I have a selection, it will only look at those two. And then I have to pick an output. So I'm going to just select my folder and I will call it Wells, Larimer, Weld 2 because I already have one. And then I can hit run. And now what this tool will do is again, just give me only the points that are in those two polygons. All right, so the tool ran, and now I have a new layer called Wells Larimer Weld 2. And if I turn off the original, then I can see that my new layer is just the points that I want. And it still takes a long time to draw because there's a lot of points. Great, so that's the clip tool. Now let's take a look at another data set. There's a really great website called Natural Earth Data. Natural Earth Data right there. And Natural Earth Data, if you click on it, take a look, they have data downloads from this tab right here, data downloads. And they have data for the whole world at different scales, so large, medium, small. Large scale is better if you're zoomed in. And they have different categories, cultural, physical, raster. We're going to get roads, which would be cultural. And they have county boundaries, state boundaries, roads. They have a ton of different stuff in here. What we're going to look at are roads right here. You can click Download North America Supplement, and that will download a shapefile of North America roads. It's just general roads, it's major roads, it's not everything, but it'll download a shapefile, sorry, a zipped shapefile, and then you can go unzip your file, put it in a folder, and then add it to the map. So let's do that right now. I've already done it. So here I have the folder where I unzipped it. There it is. And I can just add it to my map and turn it on. So these are the roads that I just downloaded. Now let's take a look at two things. My Wells layer that I downloaded from the COGCC, if I look at the properties, that one was already in UTM. That's great. I want to work in northern Colorado. UTM would be a good choice. Now we're going to take a look at the roads I just downloaded and notice what the spatial reference is. What does that mean? GCS WGS 1984. What that means is that it's in a geographic coordinate system with a datum of WGS 84, and that is not a good one for doing analysis. Right now, it's lining up with our other data, and it looks like it's in UTM because it's projecting on the fly. But if we want to do analysis on this layer, we probably want to project it into UTM. We also want to clip it down because we don't want roads for the whole country. We just want roads for our two counties. So let's do two things here. Let's clip this data and project it into UTM. So to clip it, we can just do the same thing we did before. We can clip it using the clip tool. And our two counties that we want are still selected, so we can just clip it to the Colorado counties. And we'll give it a new name. And we want to make sure that we're naming things well, so we're going to call it Roads Colorado. Actually, it's not Roads Colorado, it's Roads Larimer Weld. And then hit run. Now that we've run that, we can turn off the original and zoom in a little bit. So now we can see that we just have roads and wells for the two counties that we want. So now we've clipped the data. The next thing we need to worry about is the projection. So let's take a look back at the slides. When you're getting ready to deal with projections, you have a few different possibilities, a couple of different options here. We looked in the layer properties and it said that the layer was in GCS WGS 84. What that means is that our layer has a projection defined for it, but it's not the one that we want. We don't want GCS, we want UTM. So here are the different possibilities for you with dealing with projections. One, your data has a projection defined and it is the one you want. Well, then you're all set. Number two, my data has a projection defined, but it's not the one I want. And that's actually the situation we're in right now. So your two choices are to just let ArcGIS project on the fly, which is currently what it's doing, or really project the data. If you're going to be doing analysis and making calculations of area or length or complex overlays where you really need good accuracy, or if you're displaying a lot of data and you have a big data set, then you want to truly project the data. Don't let it project on the fly. Project on the fly will give you different results in your analysis, and it's also slower to draw. So we're in this boat right here. We want to project the data. Now let's take a look at the other two possibilities. What if your layer does not have a projection defined? If you look in the layer properties and it says unknown, that means that you do not have a projection defined, and that's a problem. It's a problem because ArcGIS won't know how to overlay it with other layers because it won't know how to interpret the coordinates. So if you don't have a projection defined, then there are two next steps. One is you do know what the projection actually is, but it's just not set right. Then you can go into the define projection tool and fix it. The other one here, and this is the biggest problem, let's say it's not defined, but you don't actually know what the layer is supposed to be. You don't know what the projection should be. Then you're up here. Then you have to do some homework and figure it out, and that can be tricky. Um, I can maybe make another video about walking through the steps for that because it's tricky. But the best thing to do is go back to the metadata or the source of the data, the website where you got it from, email the person you got it from, do everything you can to figure out what projection that layer actually is in. And then once you figure it out, then you're down here and you can just define that projection. And then the last one, which is not very common, let's say your data has a projection defined, but you bring it into ArcGIS and it doesn't line up with other data. In that case, it could be that your projection is incorrectly defined, and you need to figure out what the data is actually in and then go fix it with the define projection tool. Then there's the issue of changing the datum. So when we have coordinate systems, we have our coordinate system name and maybe a zone and then a datum. So the datum would be NAT83 or WGS84 or some variation of that. If you need to overlay data or display two layers or run a tool on data that have different datums, then you need to apply what's called a geographic or datum transformation. And a good way to think of this is when you project on the fly, it does a little bit of estimating. And so it would be like if you were multiplying 99 by 101, maybe you would just round it and say it's about 100 by 100. So it's just a way of estimating. So doing the datum is more precise math on this coordinate conversion so that your coordinates are more accurate. It will make your data line up better. If you look at layers in ArcGIS, if you have two layers in different datums, what you'll probably see is that all of your data is just shifted up and over. If you ever look at your data and everything consistently seems to be shifted up and over, then you probably have a datum issue and you need to apply a transformation. So to figure out if you need a transformation or not, it's really pretty simple. Ask yourself this one question. Are the layers I'm displaying in the same datum? If the answer is yes, they are in the same datum, then no, you don't need a transformation. Just keep using the data, you're good. If the answer is no, they're not in the same datum, if you do in fact have layers in different datums, then you need to stop right there and apply a datum transformation. In Canvas, there's a document on this, and I can have another little video made for talking about projections and datum transformations because it's a little bit more than I wanted to get into right now. So that's your flowchart, and if you think this flowchart looks familiar, you may have seen something just like it last week on the news. So that's all we were going to talk about right now in terms of slides. Let's go back into the demo and we'll actually run a project and I can show you how to set up that tool. So our roads right now are in GCS WGS84. What I want to do is go back in my geoprocessing tab and I want to find the tool to do a project. So I want to run the project tool that's just called project. There's also project raster, and that's only for raster data. So the project tool, how it works is You enter in the layer that you want to project, which is going to be roads, Larimer Weld. It will create a new output for you, which I will put in here. So I'm going to call it roads, Larimer Weld, underscore UTM. A really good naming convention is to put the coordinate system in the name, and it's just kind of a little bit easier to figure out what's what. And now it's asking me for the output coordinate system. It does not need to ask me for the input because it already reads that. It's reading that from the properties of my input data set. But it does need to know what I want my output to be in. So I want my output coordinate system to be in the same coordinate system as my wells data. So I can just click on that layer in the list and it'll set it to it. If there is no layer list, or if it's not in the list, then you click on this and then you can go browse to it. Projected, UTM, NAD 83, Zone 13. Now look at the bottom. It's asking me about a geographic transformation. The only time I need a transformation is if I'm projecting and also changing the datum. Am I changing the datum here? My input is WGS 84. My output will be NAD 83. I am changing the datum. I do need a transformation. So I'm going to click this and pick the correct one. It's giving me one as a default. That is not the one I want. That is not the datum I have. I don't have ITRF 2000. I just have the base regular plain WGS 84. So find the ones that have the combination of your two datums, and it looks like there's 3 of them here. And now you're like, well, do I want 5, 4, or 1? I will just tell you, you want 5. There's a document on Canvas that gets into a little bit more on this. So I have my input, my output coordinate system, and the geographic transformation that I want. Hit run, and now my output will truly be in UTM. So now I can turn off these roads and turn on these roads. Look at my properties, and my spatial reference is now the right one. And this is advantageous over projecting on the fly if you have a lot of data to draw, because it'll be faster and it will be more accurate for analysis. If you're just visualizing and it's not drawing slow for you, then you can just let it project on the fly. So that's all we had for this one. We're going to move on to selections in the next video. Email us if you have any questions. Thanks for watching.